Hi, and welcome back to our lesson on multiplying decimals and whole numbers. Our objective this time is about using estimation so that we can check where the decimal point is supposed to go when we're multiplying whole numbers with decimals. After you have your objective written down, you can start this review. You do need to write out the word problem. So, Patty buys 7 juice boxes a month for lunch. If one juice box costs $2.79, how much money does Patty spend on juice each month? Okay, so we need to figure out the cost of 7 juice boxes that are $2.79 each. And that's how much she pays per month. So I went ahead and broke up the decimal into 2 ones, 7 tenths, 9 hundredths. And I'll be multiplying that by 7 because that's how many juice boxes she buys a month. When I use the matrix, 2 times 7 gives me 14 ones. 7 times 7 gives me 49 tenths. And 9 times 7 is 63 hundredths here. Okay, when I write this with place value positions in mind, this would be $14. This would be 49 dimes, so that would be $4.90. And then 63 hundredths, that would be like pennies in money, so that would be 63 cents. So if I add all of those together, I get $19.53. So Patty spends $19.53 a month, each month, on those 7 juice boxes. Now that you have this information, would you be able to find how much money Patty spent in 10 months or 12 months? How might you use this information to find that? Think about it, and I'll write down what you would need to do. If you wanted to find out how much money she spent in 10 months, you would do the $19.53 a month times 10. And if you wanted to find it for 12 months, you would multiply it by 12. And that's assuming that she had 7 juice boxes exactly every single month. All right, let's get into our estimation lesson. So the first 3 problems 1 through 3, are right here. So we're gonna kind of direct your attention over to that side, and I'll cover this up for just a second. What do you notice about these 3 problems? They all have a 3, they all have a 1, and they all have a 4, and the whole number 4 is in all 3 of these problems. Do you notice anything about the decimal placement? Hopefully you notice that the decimal placement is different. So we're going to examine how this impacts the answers. Having all the same digits or the same numbers means that our answers will also have the same numbers. But hopefully we notice by the end of this lesson that the decimal points will change even though the numbers, the values are the same. So a little reminder is that you need to multiply the numerals first and then think about the units to help place the decimal point. In the past, you may have heard teachers say, ignore the decimal. Then you go back and think about where does it make sense to place the decimal. To illustrate this, I went ahead and made our charts, our matrices, or area models. So 31 times 4 I represented here. 3 tens, 1 1 times 4, that gives us 12 tens, 4 ones. And I wrote that out here. 12 tens is equivalent to 120, and 4 ones is equivalent to 4. So when I add that all together, 120 plus 4 gives me 124. And I'm just going to record that up here, 124. Okay, and that was all whole numbers, so no decimals. You remember that decimal point will go at the end here. For the next one, 3 and 1/10, I showed that up here, 3 ones, 1/10 times 4. That gives us 12 ones plus 4 tenths, which I represented right here in standard form, 12 plus 4 tenths. When we add that together, we get 12 and 4/10. Do you notice that I have a 1, 2, and 4 in my answer, but the decimal placement changes? Okay, and let's try the next one. I had to write on the next page. So I had 3/10 and 1/100, or 0.31 times 4. That gives me 12/10, 4/100, and I represented that in standard form here. When we add them together, we get 1 and 24/100. So I'm going to record that here. 1 and 24/100. And that just goes to prove that we still have the same numbers, 1, 2, 4, 1, 2, 4, 1, 2, 4, but the decimal point changes. Interesting, right? We're going to explore this further with a little work using the standard algorithm. If you have a problem that looks like this, 5 and 1/10 times 6, and you're using estimation, an efficient way to do this would be maybe using a number line or just thinking, what whole number is 5 and 1/10 close to? You can say 5. And I know my math facts. I know 5 times 6 is close to 30. So my answer when I multiply needs to be 30-ish, or around 30. If I put my decimal in this and I have 300 something as my answer, I know that my decimal's in the wrong spot. So let's take a look. 1 times 6 is 6. 5 times 6 is 30. And my decimal's in one spot, 30.6. That's very close to my estimation. Now, if I accidentally put my decimal at the end of that, I would have 306, and whoa, that is not correct based on my estimation. So that's when I know I need to go back and examine where my decimal point needs to go. And let's try it with 11 and 4/10 times 4. 11 is really close to 11 and 4/10, and I know I can multiply that by 4. That's an easy math fact for me. My answer should be around 44. Well, let's see what we get. 4 times 4 is 16. Carry that 1. 1 times 4 is 4, plus 1 is 5. 1 times 4 is 4, and my decimal's in one spot, 45 and 6/10. That's really close to 44. I could have accidentally swooped in 2 times and said 4.56 or 4 and 56/100ths, but 4 and 44 are not in the same place value positions, so I know that would be incorrect. Hopefully you can use this strategy when you're solving problems so that you know if you're on the right track. These will be your group practice problems, those 3, 1, 2, and 3. Your independent practice is right here, these 2 problems due on your own. And then finally, I have a challenge problem for you. If you're feeling like you're ready for a little challenge, it's really important to me though that you do answer these reflection questions so that we're thinking about our thinking and that we're making sure we're reflecting on this lesson. How can whole number multiplication help you with decimal multiplication? That's like when we use 6 times 5 equals 30 to help us with the decimal problem. How does whole number multiplication help you with decimal multiplication? And then the final question, how does estimation help you find the correct spot for the decimal point? Thanks so much.